Hello and welcome to another video lesson. Today we're talking about multiple angle identities. After this video, we will be able to use double angle and power reducing identities to evaluate trigonometric expressions and solve trigonometric equations. So let's jump right into it. Okay, this first concept of our double angle identities, okay, these are derived from our sum identities, okay? So our sum identities here, I've got cosine of x plus y is equal to cosine of x times cosine of y minus sine of x times sine of y. So for our double angle identities, we're going to let both of our x and our y equal theta. Okay, so this will be cosine of theta plus theta. Well, that's just going to be cosine of 2 theta, okay, on our left-hand side. And then what we have here, we'll have cosine of theta times cosine of theta minus sine of theta times sine of theta. Okay, so what we're left here, we have cosine of 2 theta. That's going to be equal to cosine squared theta minus sine squared theta. Okay, that's one of our identities there, and we won't derive or we won't prove the rest of them. I'll just go ahead and put them up. Make sure you guys write them down and understand how to use them, and we'll see some examples here in a bit. Okay, our other concept is going to be power reducing formulas. Power reducing, okay? They're called that because we're going to take, say, a trigonometric function. Say we have cosine squared theta. Okay, it's got a power of 2, right? Power of 2. And what these power reducing formulas do is they give us some output, or they change this trigonometric function with the power of 2 into some other trigonometric function with the power of 1, okay? And that can be very helpful in some calculus applications, okay? So I'll just go ahead and put those up. Make sure we write these down in our notes. And let's get into some examples, okay? Example number 1, if cosine of theta is equal to 3 over 5 on the interval 1 to pi over 2, they were asked to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Okay, so let's think about this. What does this mean? If I've got cosine theta is equal to 3 over 5, okay, well that's going to be cosine is adjacent over hypotenuse, right? So I know here that my x value here is going to be 3, okay? If I'm drawing out a triangle, this first leg is going to be 3. And I know if I have a one leg that is 3 and a hypotenuse of 5, my other leg is going to be 4. Okay, other leg's going to be 4. So this triangle is going to look something like this. Okay, like this. And then that'll be our angle there, our terminal side. Okay, and that is our right triangle. Okay, so this would be our theta here. Okay, we're asked to find sine of 2 theta. So let's go ahead and do that first. Well, let's go ahead and write down what our cosine of theta is. We know that's 3 over 5. So our sine of theta, if this is 4, this is 3, this is 5. Okay, sine of theta is going to be 4 over 5, and our tangent of theta is going to be 4 over 3, okay? So sine of 2 theta is going to be equal to 2 sine theta cosine theta, okay? So from here, I know that sine of theta, we said, was 4 over 5. Cosine theta, we said, is 3 over 5. Okay, so my sine of 2 theta is going to be 2 times 4 times 3 all over 5 times 5, which is 25. So it's going to give us 24 over 25 for my sine of 2 theta. Okay, so let's take a look at cosine 2 theta. Cosine 2 theta, we have a few different options for this one. I'm going to use this 1 minus 2 sine squared theta. Okay, so that's going to be 1 minus 2 times, well, sine of theta is 4 over 5. Okay, we're going to square that. and that's going to be, let's see, 1 minus 32 over 25. Okay, so that gives us cosine of 2 theta is going to be negative 7 over 25. Okay, negative 7 over 25. So let's go ahead and find our tangent of 2 theta. Tangent 2 theta is, it's going to be 2 tangent theta divided by 1 minus tangent squared theta. Okay, so I've got our tangent theta is 4 over 3. Okay, 1 minus now this 4 over 3 squared. Okay, so it's going to give us 8 over 3 in my numerator, and this will give me 1 minus 16 over 9, which is going to give me a negative 7 over 9 in my denominator. So this will simplify, or we can say that this is equal to negative, multiplying by negative 9 over 7. And that's going to give us a tangent to theta of negative 24 over 7. All right, taking a look at our second example, we're asked to solve cosine 2 alpha is equal to negative sine squared alpha on the interval 0 to 2 pi. So what we're going to do here, we're going to use our multiple angle ID that says that cosine of 2 alpha is equal to 1 minus 2 sine squared alpha. Okay, so I'll take this whole expression right here, and I'm going to substitute it for my 1 minus 2 sine squared alpha. 1 minus 2 sine squared alpha equal to negative sine squared alpha. Okay, so I'm going to go ahead and move all my sine squared alphas to one side of my equation. So I'm going to add 2 sine squared alpha here. That leaves me with 1 is equal to positive sine squared alpha. Okay, if I take the square root of both sides, take the square root here, got to have my plus or minus. Okay, my square root and my square cancel out. I'm left with sine of alpha is equal to plus or minus 1. Okay, so when we do that, okay, where do I have a sine, okay, of plus or minus 1 on my unit circle on the interval 0 to 2 pi? Well, I know I have that at alpha is equal to pi over 2 and 3 pi over 2. Okay, so that would be my solution for this example. Okay, taking a look at example number 3, we're asked to rewrite in terms with no powers greater than 1. Okay, no powers greater than 1. We're given cosine to the fourth x. Okay, so we're going to use our power reducing identity here. Okay, that says cosine squared x is equal to 1 plus cosine of 2x all over 2. Okay, so I'm going to say this is the same thing as cosine squared x squared, right? Okay, so I'm going to substitute in my cosine squared x, okay, for the identity here. This tells me that this is 1 plus cosine 2x all over 2 squared, okay? So that's the same thing as, keep working this up here, okay, I'll have 1 plus cosine 2x, all that squared in my numerator, all over 2 squared, which is just 4 in my denominator. Okay, I can go ahead and FOIL this numerator out. So it's going to be 1 plus 2 cosine of 2x plus cosine squared of 2x. Okay, all over 4. I'll multiply this by 1/4. Okay. Okay, I have another cosine squared of 2x here. So I'm going to do this one more time. Okay, but now I've got cosine squared of 2x. Okay, so I can use this identity, right? If I just think of what's inside here as, we'll call this alpha, or we'll call that theta. Okay, our identity just says 2 times whatever this x value was. Okay, so if I have 2x, then it's going to be 2 times 2x, which is why we have this 4x here. Okay, so this is going to be 1/4 times 1 plus 2 cosine of 2x plus 1 plus cosine of 4x all over 2. Okay, now I can go ahead and get a common denominator here of 2, so I have to multiply this by 2 over 2 and 2 over 2. So this is going to give me 1/4 2 plus 4 cosine of 2x plus 1 plus cosine of 4x all over 2, okay, all over 2. And I'll go ahead and pull that 2 out with this 1/4 over here, so that's going to be 1/8, and then I've got 2 plus 1, so this is going to be 3, plus, make that better, 3 plus my 4 cosine 2x plus cosine of 4x, okay? That would be my final rewritten expression with no powers greater than 1 for this one. All right, taking a look at our last example for this video, we're asked to solve cosine up to the 4th alpha minus sine to the 4th alpha is equal to 1/2. Okay, so for this one, we've got to use our power reducing identities again. And we're given, so for our power reducing identities, our cosine squared x is equal to 1 plus cosine 2x all over 2. Okay, so again, I'll have 1 plus cosine 2x over 2 squared, okay, just like we did in the last example, minus, now I've got this 1 minus cosine 2x all over 2, again squared, and we're squaring it because this is power to the 4th here, okay, power to the 4th, both of these are. Okay, that's equal to 1/2, not changing anything on the right-hand side. Okay, so I'm going to go ahead and FOIL out these numerators. That's going to be 1 plus 2 cosine of 2x plus cosine squared 2x all over 4 minus, now 1 minus 2 cosine 2x plus cosine squared 2x all over 4, okay? So I have a 1 and a minus 1 here, so those guys will cancel out. Let's see, I've got 2 cosine 2x minus negative 2 cosine 2x, so that's going to be a 4 cosine 2x. Okay, and then I've got plus cosine squared 2x minus cosine squared 2x, so those guys will cancel out there. And I have a denominator of 4, okay? So when I go ahead and reduce my 4's, okay, so I've got cosine of 2x is equal to 1/2, okay? I'll write that down here. Cosine 2x is equal to 1/2. Okay, and we're solving for x, okay, so we need to take the inverse cosine of both sides. Inverse cosine, inverse cosine. Okay, so my cosines will cancel each other out, so that leaves me with 2x on the left-hand side here is equal to the inverse cosine of 1/2. Okay, so what angle gives me a cosine of 1/2? That's what this is saying right here, okay? Well, I get a cosine of 1/2 at pi over 3, and I also get cosine of 1/2 at 5 pi over 3. Pi over 3 and 5 pi over 3. So I have two situations here, okay? I have two situations. Okay, so I'll go ahead and I'll just set this equal to 2x on this side as well. Okay, so now I can go ahead and divide by 2, and again on this side, divide by 2, divide by 2. Okay, so this is case 1, this is case 2. Okay, so I've got x is equal to pi over 6 and 5 pi over 6. Okay, when I solve each of those separately, okay? But now let's think, okay? Think back to the graph of cosine of 2 alpha. Okay, I'll write this up here. The graph of cosine of 2 alpha. What's my period for this graph going to be? My period is what? 2 pi over this coefficient right here, which in our case is a 2, okay? So my period for cosine of 2 alpha would be pi, okay? So I need to, since it didn't give me an interval to solve this on, I need to add an n pi, okay, to both of these, n pi. Okay, so as long as n is an integer, okay, n is an integer, don't forget to specify that, okay, then every time I hit pi, I'll be at a coterminal angle for both pi over 6 and 5 pi over 6, and that angle will again satisfy our solution here, okay, satisfy our equation. Okay, so that would be our full answer for this last example. Okay, that's all we have for this video. Good luck on your practice.